All right, so in this video, I'm going to go through an NMR analysis and show what we need to have in our notebooks, as well as, how to summarize all three of these pieces of information that we collect from our various instrumentation into getting the actual structure of a molecule. All right. And so if you've been following along in the IR video, we analyzed that IR spectra and determined that we had a primary amine. From our mass spec video, we went through and did our analysis and determined that our primary amine had 4 carbons, right? So it has this formula here, C4H11N. And now we're going to look at an NMR spectrum, putting it all together and getting our structure for our molecule. All right. One place where you can start, especially if you have a fairly modest number of carbons, is to draw out some structures. And then you can go through and nix them out depending on your depending on your NMR spectrum. What fits, what doesn't fit. All right, that's a really good approach. I'm going to sort of do this from scratch, but just, again, there's only 4 carbons here. It wouldn't be too hard to draw out all of our possible combinations and then use that as we're going through, okay? So for our NMR spectrum, and let me just show you here, I have this NMR spectrum. This is the full spectrum here up top, and then each successive image is zoomed in on one of these sets of peaks, right? So I zoomed in on this set of peaks here, and this is what I see. And that's what this file consists of. This is from this data bank of NMR spectrum that's just very helpful because they're really, really high quality spectra. We'll take some spectra in lab and you'll see, but our NMR instrument isn't really the greatest thing in the world, and so our peaks tend to be sort of smushed together, and it makes it a little bit harder to analyze what's going on. So we'll look at a few really pretty data sets at first so we can get used to the process before we graduate ourselves to the dirty data sets. All right, so these are these spectra here, and for each one of these clusters of peaks, I'm going to have some information in my notebook. And unlike IR, these spectra you aren't going to be in your notebook. I don't expect you to print them out and put them in there. All right, so instead I'm going to be looking for this information here. Okay, so the first thing is a peak label. I'm going to go through and I'm going to label each of these peaks, starting at the highest wave number and going to the smallest number, just in alphabetical order. So this one right here is peak A, peak B, peak C, and peak D. I want them in that order. All right. I don't want anybody's peak A to be this one and B this one. That makes my life more miserable grading wise. All right. So keep them consistent. We're just going to number from, or rather, I guess, letter from left to right. So that's my peak label. And then I'm going to put my chemical shift. Right? Where on that x-axis is that peak located? The other 2 pieces of information that are really important in determining your structure are the multiplicity and then finally the intensity. I guess really it's in the NMR world called integration. Okay, so this is what I need, and let's just make a note. This is for every peak in our spectrum. Okay, and then at the end, after I analyze each of these spectrum, each of my peak clusters in my spectrum, at the very end, I'm going to propose a chemical structure That's the whole point of the NMR, is that we can nail down the actual chemical structure, all right, with my peak labels. All right, I labeled all my peaks up here. I'm going to match them to my carbons in my proposed structure. All right, so I'm going to do this up here just sort of for the sake of room and all that jazz. But again, this would just be in your notebook, information that's summarized. Okay, so for this first one here, this one was peak A. That's my peak label. So when we're assigning the chemical shift of our cluster of peaks, we can sort of just look at the middle. Okay, there's 10 between these two. So this one's 2.76. So 2.755. Honestly, if you called it 2.76, I wouldn't be mad about it. Sure, it's close enough. Whoops, not PMM, ppm. Okay. My multiplicity, 1, 2, 3, 4, 5, 6 here. So that's a sextet, which means that this particular carbon has five, or a particular cluster of hydrogens has 5 neighbors. And then lastly, and this is another way in which I'm kind of nice giving this database of information, is the integration is given to you very clearly. So this is an integration of 1. So I'm going to go down the line and do that to each of my set of peaks here. So this is B. This is 4.2. So 4.142. 1.42 ppm. This is 1, 2, 3, 4, 5. So this is a quintet. All right, a quintet means that we have 4 neighbors. And lastly, my integration is again given to me at the top here. My integration value is 2. C is at 1.14. It's a doublet, so just 1 neighbor. And my integration value is 3. And then lastly, I have a 0.91 ppm. This one was D. It is a triplet. So it has 2 neighbors. And then lastly, my integration is 3. All right, so here are my peaks. Here's everything I need summarized. Now I have to go ahead and propose my structure. So again, let's just think of all of my possible primary amines here with 4 carbons. So there's 1. Let me pick up that nitrogen, move it over here. Are there any more? That's all I can think of. These are primary amines, so I can't like stick the nitrogen between 2 carbons. So sure, I think that's it. All right. So looking at this here and looking at our spectra, we could go ahead and narrow it down. All right. There's something else I sort of want to point out about analyzing NMR spectrum is there's 2 other things about this spectra that really jump out to me. One is that the lowest possible number here, which is usually the lowest ppms, are in terminal carbons. And indeed, this one is a integration of 3, so there are 3 hydrogens, and it's next to a carbon with 2 neighbors. So like all of a sudden I know that I have an ethyl group in this molecule, a CH3 bound to a CH2, bound to who the heck knows what else. But I very clearly have this methyl carbon that's next to only 2 other hydrogens. So that's kind of the first thing that jumps out to me. The other thing being that I have this group that has only 1 neighbor, which means that there's a carbon somewhere that has only 1 other hydrogen on it, which checks out if my functional group is located in the middle of my molecule as opposed to sticking off of one of the ends. All right. So oftentimes you're just sort of going to try to put piece together this information. If you start with possible structures, that really, really helps because then you can go down the line. But there are some of the other features that I mentioned here. In this case, this group right here is the furthest up. That means that it has my functional group on there for sure. I mean that they always shift at a higher ppm, the carbons that actually bear that functional group. And that has that one integration, so there's only one hydrogen. So all signs are pointing to this molecule right here, given that that's my primary amine that matches my spectrum here, but also matches my NMR information. Okay, so to finish this off, I've got my analysis for each of my peaks. Last thing I'm going to do is I'm going to propose my chemical structure here. I'm going to make it a little bit bigger, actually. My 2-butanamine. Cool. Now I have to map these. I have to map my peaks, A, B, C, to my carbons below that are giving those signals, right? I guess to the hydrogens on those carbons, but yes. So again, my lowest here is going to correspond to the methyl group that's furthest away from my functional group. So that's D. C is then going to be that cluster of 3 with only one neighbor. So that's C, the other methyl group, but notice that it's closer to the functional group, so a little bit higher ppm. I have my quintet with 4 neighbors here. And my, what is that, sextet, my 6 or my multiplicity of 6, so 5 neighbors, that goes in the middle there to that 1 carbon. So here's my chemical structure that's mapped to my peak analysis above. And that's what we need for our spectra, or for our lab notebooks. IR, we get our functional group. Mass spec, we get our chemical formula. And then in NMR, in our analysis of our NMR, that's how we finally get to the unique structure of our molecule.